Hello students. So we are going to start today complex numbers. Session number 1. This also one of the most important chapters in mathematics. And first of all, we must know the difference between real numbers and complex numbers. Actually, what is real number? All numbers can be marked on a number line. These are real numbers. Or if the square of a number is positive, very important, if square of a number is positive, then the number x is considered a real number. This is real number, simple definition. So the real number is a superset of rational number, irrational number, or we can say the real number is a universal set of rational number, irrational number, whole numbers, counting numbers, all. A non-real number, but the condition of non-real numbers, just opposite. If a square of a number is negative, usually the square of a number cannot be negative in case of real number, but in case of non-real number, the square of the non-real number can be negative. Then the number x is non-real number, does not belongs to R. Does not belongs to R. For example, if we take a number x equal to root of -2, then what about the square of the number -2? Is negative. If we take x equal to -10, then square of the number -10, negative. That's why the square root of any negative real number cannot be real number. And these numbers are called imaginary numbers or non-existing number. Non-existing numbers. What is the basic unit of non-existing number? Basic, fundamental. Basic or fundamental unit of imaginary number or non-existing number. is taken as square root of minus 1 and denoted by I in the name of iota. Iota means non-existing one. Non-existing one. Okay. So remember student, the root of minus 2 would be written I in the root of 2. So this is an imaginary number. Root of 2 is a real number. The coefficient of I, the real number being coefficient of I, this is imaginary number. Any number or real number having coefficient I, it is a basic unit of non-existing number or imaginary number, is generally known as imaginary number. Okay. So the imaginary number, how to plot imaginary number? Just draw a perpendicular line to a real number line. The perpendicular line is used to represent imaginary number. Then every point on the first quadrant, second quadrant, third and fourth quadrant other than horizontal line and vertical line are complex numbers. The points on the horizontal line purely real number. The point on the vertical line is purely imaginary number. The points on the plane between the horizontal and the vertical lines are generally known as complex number. So the vertical line are taken to mark imaginary number. So this is imaginary number, or we can say imaginary part of the complex number. The horizontal line is used to represent or take real number or real part of the complex number. If we take any point on the vertical line, it will be purely imaginary number. The point on the horizontal line is purely real number. If you take a point in the plane, okay, and with the coordinates along x direct, along real axis it is x, along imaginary axis the distance y from the origin, then the ordered pair x comma y represent the complex number x plus iy, because the x is the real part of the complex number, y is the imaginary part of the complex number, mean y and I is nothing but imaginary number. So therefore student, the x plus iy is the standard form of complex number. X plus iy is the standard form of complex number. Then what is standard form of complex number? A complex number z equal to x plus iy. One important point you have to remember, here x and y or x comma y are real numbers and I is iota, imaginary unit, fundamental units, and we can say x as a real part of the complex number, real part of the complex number, and y is said to be imaginary part of the complex number, or in short X is real part of RE, real part of Z, and Y is imaginary part of Z. Then Z can be written real part of Z plus I in the imaginary part of Z. This is more general form of a complex number. More general form of complex number. Okay, if you look at the plane to represent a complex number, any plane used to represent a complex number. A plane is used to represent a complex number is known as complex plane. This is totally different from Cartesian plane. Complex plane or organ diagram, name of the mathematician. Organ diagram. Okay, so with the help of the organ diagram or complex plane, if we connect the origin, the point of intersection of real axis and imaginary axis with the point A having the affix x plus iy, the distance OB is known as magnitude of the complex number. The distance of the point A on the complex plane from the origin is defined or known or called magnitude or modulus of the complex number. So the opposite side, this is theta, the direction of complex number about real axis. What is theta? Here theta is direction of complex number about real axis. What is a technical term of theta? Argument of Z or amplitude of Z, okay, and denoted or obtained by the formula tan inverse of imaginary part of Z by real part of Z. Okay, this opposite side, imaginary part of the Z, the adjacent side of theta, real part of the Z. So the amplitude formula tan inverse of imaginary part of Z by real part of Z, and using Pythagoras theorem we can get an OA from the figure. OA is, it is x square plus y square, or real part of Z square imaginary part of Z square. This is OA square. What about OA? Take positive root. So this is a formula, another formula. OA is nothing but modulus of the complex number is positive square root of sum of the squares of real part and imaginary part of the complex number. So dear student, the most important and fundamental formula, modulus and amplitude of a complex number. The modulus is positive square root of sum of the squares of real part of z and the imaginary part of z. And amplitude is a tan of amplitude. Tan theta is opposite side, that is imaginary part, adjacent side, that is real part of z. If you take the complex number in various quadrant, now we have taken from the first quadrant. In case the point is taken in the second quadrant or third quadrant or fourth quadrant, the modulus formula is going to be constant. According to the quadrant, the amplitude theta may differ, because the angle will not be acute. Angle will not be acute. Acute more than 90, more than 180, more than 270 in the fourth quadrant. That we will discuss when we discuss the alternate form of complex number in the name polar form. Polar form. Polar form means the complex number. This is known as Cartesian form. Very important. The standard form is Cartesian form. This is Cartesian form. Understood? Dear student, then what are the algebra in complex number? One is addition of complex number. If we take z1 x1 plus I y1, z2 x2 plus I y2, then z1 plus z2 x1 plus I y1 plus x2 plus I y2. Very important point, we cannot combine real number and a non-real number together. We cannot make it as a single number. And 1 plus I is cannot be substituted by a single number a. We cannot combine. That is why the separation must be maintained. Real part and imaginary part always separated. So now what to do? Two real number can be added or subtracted, as well as two imaginary number can be added and subtracted. The addition of two complex number means we have to combine real part of two complex number together and the imaginary part of two complex number together. This is a method of adding two complex number or difference of two complex number. Difference of complex numbers. z1 minus z2 x1 plus iy1 minus of x2 plus iy2, that is x1 minus x2 plus I into y1 minus y2. Okay, so difference of real numbers, real part, and difference of imaginary part is difference of two complex numbers. Difference of two complex number. So in the same way, another one, product or multiplication of two complex number. Multiplication of two complex numbers. The multiplication of two complex number, z1 into z2. You can take straight away. X1 plus iy1 into x2 plus iy2. Okay. Now just apply distributive law. X1 of x2 plus iy2 plus iy2 of x2 plus this x1 plus iy1, this should be 1, x2 plus, the suffix should be 1, x2 plus iy2, and opening the bracket using distributive law, x1 x2 plus I x1 y2, okay, plus I y1 x2 and plus I square y1 y2. Dear student, I equal to root of minus 1, then root of minus 1 the whole square equal to minus 1. Therefore, I square equal to minus 1. Now x1, x2 real numbers. I square equal to minus 1. So minus 1, y1, y2 real number. y1, y2. So this is real part of the product z1, z2, and take I and write all the coefficient x1, y2 and plus y1, x2. So from this, the product of complex number can be generalized. How to generalize the product of the complex number? In general, z1, z2 equal to real part of z1, real part of z2 minus imaginary part of z1, imaginary part of z2. This is real part of the product plus I into mixed case, real part of z1 will multiply imaginary part of the second complex number plus, here the middle one minus, here plus, always. This is a standard formula, and imaginary part of z1 will multiply real part of z2. So with the help of this formula, we can find the product of two complex number in simple manner. So let us discuss one example to understand to multiply one complex number with any other complex number. One example, let us take z1 equal to 1 minus I, z2 equal to 2 plus 3I. Now we can write z1, z2, just multiply real part 1 into 2, 2 by formula minus multiply 2 imaginary part minus 1 into 3 minus 3. Okay, this is real part plus I. Here real part, the other side imaginary part, mixed multiplication. 1 will multiply 3 and I will multiply this. So 1 into 3, 3, because I was already taken common factor out of the bracket. So 3 and 2 into minus 1, minus 2. Okay. Then what about Z1, Z2? We have got it. And 5 plus I. 5 plus I. So using formula, you have to remember. Otherwise, a regular method can be followed whenever we are not in position to recall all important formula. Go regular method with the confident. It will take 1 or 2 minutes extra, but the answer will come if you approach with confident. The confident is very important. So this is product of two complex numbers, and the same way another operation, algebra of complex number and quotient of complex number. Quotient of complex numbers. Z1 by Z2 is equal to x1 plus iy1 and x2 plus iy2. Okay, whatever be the expression in terms of complex number, we should target to write or to convert the given expression in the standard form. Real part and the imaginary part should be separated exclusively without any confusion. For that, the denominator should not be a complex number. We have to convert the denominator as a real number. The conversion of complex number into its real number is known as rationalization. But a rationalization, irrational number, in order to convert irrational number into rational number, rationalization. Just we can say here and conjugation process. So we are going to discuss what is the meaning of conjugation. So simply I am telling, in order to write Z1, Z2 in its standard form, what can be done? X1 plus iy1, x2 plus iy2 is multiply and divide by the conjugate of the denominator. Conjugate of the denominator means and there won't be any change in the real part. Imaginary part, number will not change, only sign will change. Then that is graphical interpretation will be discussed in the coming class. Okay. Then what is rationalization factor of x2 minus iy2? X2 minus iy2 and x2 minus iy2. If you multiply the numerator following the rule x1 x2 by formula minus, so already another minus, so y1 y2 is the real part and plus I into x1 y2 minus x1 y2 and y1 x2 x1, this is y2 y1 x2. The denominator, if we follow the same rule, we can get a plus b a minus b x2 square minus I y2 square. So I square will be minus 1 minus or minus plus. So x2 square plus y2 square. Look at the denominator. There is no item. This is purely real number. Now we are in position to separate the quotient of complex number in the standard form. What is real part of z1 by z2? x1 x2 plus y1 y2 by x2 square plus y2 square. This is real part plus I in the imaginary part, and x2 y1 minus x1 y2 by x2 square plus y2 square. This is imaginary part of the complex number. If you remember, you need not memorize this formula. You must know the process of that is conjugation process, and to convert the denominator into a real number. We'll discuss one example. Let us try to write the standard form of 3 plus I by and 2 minus I. In order to write in a standard form, that is separation, real and imaginary part, and let us follow the rationalization process. Multiply and divide by conjugate of the denominator, 2 plus I, 2 plus I, just a normal multiplication, 3 into 2, 6, by formula minus 1 into 1, 1, plus I, mixed case 3 into I, it is 3, I into 2 plus 2, the denominator, and 2 square plus 1 square. So 6 minus 1, 5, and 5 by 5, that is 1, and 3 plus 2, 5, denominator also 5 plus I. So remember student, 3 plus I by 2 minus I is 1 plus I, mean now we have got real part of the complex number 3 plus I by 2 minus I is 1. Imaginary part of the same complex number 3 plus I by 2 minus I is 1. So, and today, and we have discussed the fundamental, only fundamental. What is complex number? What is the difference between complex number and real number? How to represent complex number? And what's the meaning of modulus and amplitude? And algebra of complex number, addition, subtraction, multiplication, and divisions. That's all we have learned today. The continuation in the next class, coming class. Thank you, students.